5, 6 probably. So whenever we talk about inverse functions, okay, an inverse function is really just going to be, we're going to rewrite the function that we're given, okay, and we'll go through the steps of that in a minute. But being able to solve an inverse function, you're going to have to be able to solve like a literal equation where you're basically going to have two variables and you need to isolate one variable. Okay, with any sort of inverse function, you're always going to isolate the y value or the f of x. Okay, we'll change the f of x from f of x to y equals. Okay, with all of these. But with all inverse functions, you are going to solve for y. So that means you're going to get y by itself. How you do it and which side you put y on is completely up to you. In some cases, it's going to be easier for you to move the y value over to the right than it is to keep it on the left side. Some students are going to keep it on the left side every single time, and that's all right too. Okay? It's up to you as far as how you do this. Okay? So whenever I have a literal equation, whenever I'm solving for y, if I have 3x minus y equal to 4, I need to get y by itself. So in doing that, whenever I'm going to get y by itself, again, it's completely up to you what you do. Some of you may have been taught you always keep whatever you're solving for on the left side and put everything else over to the right. That's completely all right. I will have some students that will take that 3x and they will subtract it over to the other side. And they will have negative y equal to negative 3x plus 4. Next step, I can't have it be a negative y, so that means I need to divide every single part by negative 1. Okay? Not just the first part, but every single part after it. So then if I have y equal to negative 3x divided by a negative 1 is just going to be a positive 3x. And then positive 4 divided by negative 1 is negative 4. This is solving for y. Now, some of you may move the y over to the other side and have 3x equals 4 plus y and then move the 4 over. You're still going to get the same answer. It's completely up to you. Okay, if you have a variable in front of your value, then what you want to do, so like on 2, where if I have 3x minus 2y equals 10, and you're going to move that 3x over to the other side, doing that first, if I have negative 2y equals, I always put the x value in front, and then my constant on the back side. I need to divide everything here by negative 2. So whenever I do that, I'm going to have y equals, leave everything as an improper fraction. So like negative 3x over negative 2 is just going to reduce to 3 over 2x. Now I can divide positive 10 and negative 2 and I can get a negative 5. All you're doing with any of these is solving for y. You're isolating the y variable and then you're getting everything else over to the other side and solving from there. Now, I'm going to skip over the partner spot. Whenever we solve any or we find the inverse of any function algebraically, okay, you're going to basically do three things. The first thing, and if you follow these steps, you will be just fine and everything. As long as you can solve for the variable, you'll be okay. So first thing I need to do is if it starts out as f of x equals and then your function, you need to change the f of x to a y. So like on the first one, if we do step 1, it says find the inverse of f of x equals 3x minus 1. So the first thing that I'm going to do is I'm going to change, instead of it being f of x equals, it's going to be y equals 3x minus 1. Step 1 is complete. Now, step 2. Whenever it says step 2, it says to switch the x and the y in the equation. It didn't say anything about the numbers associated with it. It just said switch the x and the y. So instead of it being y equals, so here was step 1. Step 2, all I'm going to do is I'm going to make it x equals 3y minus 1. No values were changed. The only thing I did was switch where the x and the y were. Instead of it being y equals 3x minus 1, it became x equals 3y minus 1. So, step 2, complete. Step 3, solve the equation for y. So what we just did at the very beginning, you're going to do right here. You're going to isolate the y value. The good thing is your x value is going to be by itself. You just have to move everything else over to the left side. So I'm going to have to add 1. So I'll add 1 to both sides. So I'll have x plus 1 equals 3y. Now I need to divide everything by 3. So whenever I do that, I'm going to write it up here over to the right. I'm going to have 1/3 x plus 1/3 equals y. That is your inverse of your original function. All you're doing with an inverse function is you're just writing another function. Okay? You're writing another function where your x and your y values are just going to flip spots. So like if you would plug in values for your x and your y, or you plug in a value for your x, it would get an output of your y value. All you're doing with the inverse is if you would plug in or you would put in a different input value, if you would put in the opposite, you switch your x and your y values, you're going to get the inverse function. Okay, is all you're going to do. Now, here on the second page, it says find the inverse of f of x equals the x squared, where x is greater than or equal to 0. Okay, so this is important because if we have the function, it says then graph the function and its inverse. So if we graph the function, and the key part is here that it says, it kind of gives us a stipulation, because the inverse, if we just stick with x squared, normally it would look, we'd have a point here, there. We'd go up to 2, 4, we'd go up to 3, 9. And we would have all the values. So what it's saying is it wants to know what the values when x is greater than or equal to 0. It doesn't want the left side of my parabola. Okay? Because whenever we find the inverse, with any graph, all the inverse is going to do is it's going to basically map over this line right here. Okay? So what that means is my inverse function is going to just go straight over. It's going to be reflective over that imaginary line y equal to x. The problem is the original function is a function of x squared. If I would have this left side of my graph, so if I would have the points 2, 4, okay, if I had that red side there, the problem is whenever I map it back over, it's going to look something like this here. What's the problem with the green one though? Is the green graph, is it a function? No, why not? Because what doesn't it pass? The vertical line test. Okay? So because of that red spot or the red portion or the negative portion of my original function, if I would do the inverse, that's not, the green one's not going to pass because it's not going to be the full thing isn't going to be a function. okay, whenever I do the inverse. So that's why I can only stick with one part of it and not both sides. I can only look at the values when x is bigger than 1, or excuse me, bigger than 0. Okay, whenever they're all positive. Because whenever I actually take y equal to x squared, and then, so I change the f of x to y equals, and then I switch the x and y values, then I need to solve for y, so I need to take the square root of y, and I'm going to have the square root of x equals y. Okay? I'm only going to have the positive version because I can't have the positive and the negative version here, because then it wouldn't be a function. Because then, if I'm going to map everything here in green, all it is just my square root function that we did back with 5.3. All the inverse is going to do, if my point right here is at 9, 3, the point up on the black graph here is at 3, 9. What did we do whenever we found the inverse? What did we do with my x and my y values? My x value for the black graph is 3, my y value is 9. What's the difference between the black graph and the green graph? If my other point's at 9, 3, my original point was at 3, 9, what did I do with my x and my y values? Just flipped them. Okay? No matter if both of them are negative or both of them are positive or vice versa, okay, all you're going to do is whatever your original is, the inverse is just going to be the opposite. I'm just going to take my x value and put it in the y spot, my y value and put it in the x spot. Okay, they're just switching places. Okay, the signs don't change. The numbers just change locations is all that's going to happen with any sort of inverse function. Now, the last thing is the horizontal line test. The horizontal line test is a lot like the vertical line test without having to actually redraw the new graph. Horizontal line test just says if you can draw a horizontal line, okay, you're used to vertical line test, it's the same thing. But yet, instead, if you can draw a horizontal line, if it only passes through one point of your original function, then that means that the inverse is also going to be a function. Whereas, if it passes through 2 points, similar to the one on the right, the inverse is not going to be a function, because whenever we map it over, just like we did before, if I map the whole original of x squared, like it is in the bottom right where that picture is, it's not going to work as far as flipping the whole thing over, because then the inverse is not going to pass the vertical line test. Does that make sense?